Welcome to lesson 105. We're talking about surface area of right solids and steel. Alright, you guys are surface area experts, right? When we talk about surface area, we're really talking about the wrapping paper around your present, right? How much wrapping paper do you need to completely cover the outside of the box? Or we talk about painting that box, or painting, in this case, prisms or different things like that. And that's what we refer to when it comes to surface area, the area of the surface. How interesting. Today we want to look at what does it mean to find the area of a surface. So let's go ahead and jump right into this. As we look at our shape here, we want to identify, first of all, how many surfaces we need to find the area of. Because we have a triangular prism here, we know that we have the triangle on the front side, and we also have the triangle on the back side, so that gives us two faces that are exactly the same. That's what makes it a prism. Right? Then we have our face here, and then of course the angled face here for three more faces. Right? So we're going to call one the back, call back. I'll write over here for bottom, right? Or base, we could also call it, and then we'll call the slant our last one. Okay, from here then we just need to find the area of these things. Let's start with our triangles, because triangles have a tendency to be the harder ones, right? Because we have this unique formula, 1/2 the base times the height. So, if I'm looking at my shape here, I need to understand that my triangle has a height of 3 and a base of 4. So we said height of 3, base of 4, so 1/2 times 4 is 2, 2 times 3 is 6. Okay, 6 feet squared, because we're dealing with area. Right, and this is a triangle, and of course we do have two of them, so we can't forget there's two of them when we get to our final calculation. Alright, next let's take the slant. Right? We see that we have 5 going this way and 7 going this way to make a rectangle. So 5 times 7. I'll write that over here. 5 times 7. 5 times 7, of course, is slant is 35 squared. Right? Now let's take the bottom or the base. If we look at the bottom of or the base, we can now say, okay, we got 4 feet by 7 feet. 4 feet by 7 feet. 4 by 7 gives us an answer of 28. And then, of course, we have the back, which is 3 by this distance, and of course, this distance corresponds to this distance. So the back is going to be 3 times 7, or 21. The back. And just like that, we've solved this. And just so we don't forget to multiply this by 2, because there are two sides with those dimensions, we would make that 12. And now all we have to do is take our 12 plus our 35 plus this and add them all together. Now I'm going to group these two together because 2 plus 8 gives me a 10. And so 28 plus 12 gives me an answer of 40. Right? Then if I combine these two together, because that math is not too hard, I get an answer of 56. And then simplifying, my final answer is 96 feet squared, or total surface area. So what do we do here? What we have to do to find surface area of an entire shape is we need to find the individual area of each of the sides. So first and best thing to do is identify from all your different sides, and then go ahead and solve the area. Moving on. Along with surface area is a term known as lateral surface area. This is kind of like if you had a can of soup and you peel the paper label off that can of soup. That paper label that comes off is what we would call the lateral surface area. So it's the surface area minus, we're not going to count this base, and of course if I were to be an awesome artist, I would say the bottom of the can would be the other base. So we don't take the top or the bottom when it comes to this. Right? In other types of prisms, right, if I were to ask you to find the lateral surface area of this triangular prism, I would say that the top and bottom, the two sides that are exactly the same, that everything's joined together, are the two triangles. Right? So to find the lateral surface area of that, I would just not use the triangles there. But since our sample has to do with a cylinder, let's work with that cylinder. Alright, so we're not going to worry about that. So what do we need to do? To do this, we need to know this distance here, which we better know as circumference, and then we're going to multiply by the height. That's what the paper, if we were to unroll it, it would be that square, and this would be the height of 10, and this distance would be the circumference of the circle, since it's wrapping around. So, to find the surface area of the label of the soup can, also known as the lateral surface area, we're going to take circumference, so that's 5, we need to turn that into a diameter, so 5 times 2 is 10, so 10 times pi. Times pi, of course, is 31.4, and then we're going to go ahead and multiply that by the height of 10. So we realize that this 10 was the diameter, our second 10 is the height. So we're going to take this 31.4 and multiply by 10, just like that. And by doing that, we have found the lateral surface area, which is 341 centimeters squared. Not important. All right, part B then says, okay, what if I wanted to know the total surface area of the soup can? So we don't want to know just the label. We've already solved for the label, so we can keep that. That covers all of this section. But now we got to go back and we got to solve for the top and the bottom. We have to find the area of this circle right here. Now I've covered up all the numbers unless you have them memorized. So we need that 5 there. So to find the area of a circle, we're going to take pi r squared. And because there are 2 of them, right, in the end we're going to multiply by 2. But first let's just solve for the area of one of them. The area of one of them, of course, is 5 times 5, which is 25. And then we're going to multiply by pi, which is 3.14. Now, if you have your trusty-dusty notes next to you, you know that we were just doing problems like this in a previous lesson as we dealt with arcs and all that fun stuff. So if you have your notes in front of you, you can flip back and find 3.14 times 25 real fast. If you don't, then you have to solve it. So we get 0, 31.9. That's fine. Pause the video again. Alright, double check my work. Solve it. 78.5. That makes way more sense. 78.5. And that's the area of one of the circles. So I'm going to multiply by 2 and get a final answer of 156. 157. 157. Right? So this is the area of the top and the bottom. Now we got to add it to the lateral surface area. Whew. Okay, let's do it. 157 plus 314 is 1, carry the 1, we got 7, carry, nope, carry, and we got a final answer of 471 centimeters. So far as we've looked at this lesson, we're realizing that it's not necessarily a lot of work, it's just kind of a lot of steps sometimes. Uh-oh. Surface area of spheres. 4 pi r squared. Okay, I can do that. I can take my area of the circle and multiply by 4. And that's going to give me surface area. Sounds doable. Alright, so let's do this. Find the surface area of this tennis ball. Put that back. Something right there. Surface area of the tennis ball, meters square second. Alright, let's break this problem down then. So we have 4 times pi, we got that. Radius, of course, radius squared is 3, right? Because 6 centimeters is the diameter, right? So as we break that down, we have 3 squared, so that gives us 4 times pi equals 9. So we solve that. Okay, so if I break that down then, I'm going to multiply all that stuff together. And so that's going to be 36 times pi, 36 times pi. Use my mental calculator and come up with this. Or I use my actual calculator, one of the two. And of course, because it says to the nearest square centimeter, I can round like that to 6 square centimeters. And I have this problem solved. Yes. Alright. All of this wonderful information coming at you. So I leave you with this. Surface area, complex shape, compound shape. Break it up, break it down, solve. That's your sample. We're working with surface area. Lesson 105.